Hello, everyone. My name is Andy Lezondi. I'm a mathematical literacy teacher for grade 11. Right? Okay, so today we're carrying on where we left off yesterday. Today we're looking at scales, right? But before we look at scales, should you have any questions, feel free to pick up your hand. If I ask you a question, please respond using the chat, right? And then keep your videos switched off, right? So let us start. Okay, for today's lesson, as I've said, we're looking at scales. Okay, first of all, I gave you homework yesterday. So before we proceed, we'll look at yesterday's homework. Okay, basically, we read this yesterday. I'll quickly go through it. Then you guys can maybe respond by giving me your answers. Okay, it says, Tina has a greenhouse in which she grows strawberries. The sprinkler system in the greenhouse sprays a fine mist to ensure the strawberries get enough water. The strawberries are washed for a total of 2 hours and 45 minutes every day, or are watered for a total of 2 hours. So this is important. 2 hours, 45 minutes. They are watered for this long every day. And the temperature in the greenhouse is kept constant at 25 degrees Celsius. Okay, the clock below shows the time each morning when the sprinkler system is switched off, right? So they obviously opened the system before, sprinkler system before, and they're now closing it at this time, right? So obviously you should know what this time is, right? Okay, yesterday we said this time was 11 something, right? Okay, 11:56, right? Okay, I'm just going quickly through this, right? I'll give you an opportunity to respond later, right? So this is the finishing time, right? This is the finishing time. Now the question says, determine the time the sprinkler system is switched on, right? So obviously it was switched on 2 hours, 45 minutes before, right? What was that time, right? Okay, now for those who've done my homework, this is your opportunity to give me the answers, right? What time was the sprinkler switched on? If it was switched off at 11:56, and the duration of the watering was 2 hours, 45 minutes, right? So if you know the answer, you can basically write the answer for number 1. Now for number 2, it says the thermometer Tina uses is calibrated in degrees Fahrenheit. Obviously, when they say degrees Fahrenheit, we're converting between degrees Celsius to converting to degrees Fahrenheit, right? So we're moving from Celsius to Fahrenheit. Determine the temperature reading on her thermometer if the required constant temperature of 25 degrees Celsius has to be maintained, right? So in this case, it's actually simple. All you need to do, you basically need to plug in your 25 degrees Celsius into your formula, right? And then solve, right? If you did my work, feel free to write both your answers on the chat, right? But let me give you my answers so that you can compare your answers to my answers. Okay, there's my answer for number 1. 11:56 minus 2 hours 45 minutes, right? So you need to write in a 24-hour format, right? And then this person started watering at 9:11, right? So that was simple. Probably give you a mark for that and a mark for that. For the second one, we're converting degrees Celsius, which is 25 degrees, to degrees Fahrenheit. Okay. See, we all make this mistake, so make sure that you don't write the incorrect units. So in this case, I'll give you a mark for correct substitution, right? 25 degrees must go there. You can see degrees Celsius. Simplify, then your answer is 25 degrees Fahrenheit. Make sure that this is an F, right? For you to get full marks. Okay, now let's start today's lesson. At the end of today's lesson, you must know the following: how to work with number scale and a Pascal, right? So basically looking at a number scale and we're looking at a Pascal, right? This goes for maps and plans, right? Understand the advantages and disadvantages of each type of scale, right? So advantages and disadvantages of both these scales, and then how to determine the most appropriate scale in which to draw a map, a plane, or a model. So basically here, I'll show you how to convert, how to make a scale, basically, like how to make your own scale. Okay, let's continue. Okay, number scale. Number scale is also known as a ratio scale, right? Because it is written as a ratio, right? It's written in this format. 1:2, and then a number. In this case, 1:100, right? 1:10, 1:20, 1:to anything. But it's a number. Numbers, that's why it's called a number scale. Sometimes it's called a ratio scale because it's written as a ratio, right? Obviously, in between there's a colon. Okay, what does 1:100 mean, right? In an exam, they'll usually ask you what 1:100 or 1:to anything means, right? So in this case, 1:100 actually means that 1 unit on paper, right? You can say on the map or on the plan, right? But to simplify my life, I just say on paper. 1 unit on paper represents 100 units in reality. So 1 unit on paper, so this is the paper distance or paper measurement. If you're measuring 1 unit on paper, it will represent, here the key word is represent, not equal to, but represents 100 units in reality. So this is real life. So this is real life, okay? Notice there are no units in the scale, right? There's no centimeters, they're just plain numbers because it's a ratio. Okay, now if I'm measuring in centimeters, for 1:100, it will basically mean 1 centimeter represents 100 centimeters if you're measuring in centimeters. Now, if you're measuring in millimeters, it will be 1 millimeter represents 100 millimeters. So depending on what you use, right? Obviously, we need to. We're only looking at centimeters and millimeters. We're not measuring on the map, right? You can't measure meters because meters are too large for your map. Okay, and next, how to use a number scale, right? Okay, this is how you use a number scale. Right? First of all, you need to measure the distance on the map. So step number 1, measure the distance on the map. This is called a map distance, right? Obviously, you must use a ruler. Now, when you measure, let's say your map is a map of South Africa, and there's, let's say you stay in Joburg, so Johannesburg, and you're visiting your cousin for holidays in Durban. So when you measure, right, you must not measure from the names, right, but you must measure from the dots. Very, very important. Measure from the dots, not from the names, right? What I encourage my learners to do is basically draw a straight line with a pencil, right? And then measure. If you're measuring like that, you will be, obviously your values will be incorrect. So this one is incorrect, this one is correct. Okay, now after doing that, you multiply that measurement by the real part of the scale. Remember, there's the paper distance and the real part. So the number on the right hand side of the column, you multiply by that figure, right? Okay, in order to get the real distance. In other words, you can use this formula. Real distance is equal to map distance times scale, right? You need to know this formula off by heart, right? If you're using this method. Real distance is equal to map distance times scale, right? Let me give you an example. Okay, let's say you're given a map with a scale of 1 to 50,000. So that is your scale. You measure a distance of 15 centimeters on the map. So this will be your map distance, right? What is the actual distance? In this case, I've used the word actual. They could also ask you what is the real distance, right? They could also ask you what is the real life distance. Okay, they could also ask you what is the length in reality. So all of those words mean the same thing, right? So I need to know my real distance, my actual distance. I've measured my map distance using a ruler, right? This is given, by the way. And my ratio scale, right? The real part of the ratio scale. This is the real part of the ratio scale, right? This is the paper part. So in this case, I'm multiplying by 50,000. So my answer will be, my formula first, real distance is equal to map distance on scale. My map distance, the distance which I've measured on the map is 15 centimeters times 50,000, right? So obviously I'm multiplying here centimeters. My answer will be in centimeters. So my answer is 750,000 centimeters, right? But they said they want to know that distance in kilometers, right? So all I'm doing now, I'm changing my actual distance, which is in centimeters, to kilometers, right? Okay, this conversion, okay, this conversion you need to know off by heart as well. 1 kilometer is actually equal to 100,000 centimeters, right? 100,000 centimeters, right? Remember that 1 kilometer is equal to 1,000 meters, right? Right. And keep in mind that 1 meter is equal to 100 centimeters, right? So when you're converting kilometers to centimeters, you now have 1, 2, 3, 4, 5 zeros. Right? So it's equal to 100,000. Right? You can also use the method that I showed you last time, right? Which basically, let me just quickly go through it. You are basically using a mnemonic, right? With K representing a kilometer, H, remember I said K is a kilometer, this you must know. H is a hectometer, you don't need to know this. So basically what you need to know is the mnemonic that I gave you last time, which basically says K, kilometers kitchen, has done, right? Has done much damage catching mice, right? So you need to know your kilometers, you need to know your meters, centimeters, and millimeters. So in this case, you're moving from kilometers to centimeters. What is my conversion? So I need to write a 1 from kilometers, and I'm adding zeros all the way to a centimeter. I'll add 1, 2, 3, 4, 5, right? So I know that 1 kilometer is equal to 100,000 centimeters. So I divide by 100,000, and my answer is 7.5 kilometers, right? So that one is simple, I think. Next one, let us look at Pascals, right? For Pascals are also called line scales or linear scales because they work in a very, very same way, right? Obviously, when I say line scale, I mean something like this. Sometimes you're given something like this, right? Basically a line. When I say a bar, you're given the actual bar. Think of a bar of chocolate or something along those lines, right? So obviously they work very same way. In your exam, you can be given a line scale or bar scale, same thing. Okay, basically a bar has segmented bars, a line has intervals, as you can see there. You can see bars which are separated. Okay, it is represented like this. So there's your bar scale in this case. These values at the bottom, they represent the real distance. So these are real distance. So if you're given a map, right, this distance, right, on the map actually represent 10 meters in real life, right? So it's actually easy to work with the bar scale once you understand that. Okay, each piece or segment of a bar represents a given distance is labeled underneath, as I've said, right? So on the map, let's say this is, just making an example. This is your house, right? This is your neighbor's house, right? If on the map they're separated by this distance, maybe let's say 2 centimeters, that means in reality they're actually separated by 10 meters, right? But let me continue. How to use a bar scale. You need to measure how long one segment of the bar is using your ruler, right? So in this case, you need to know how long maybe this segment is using a ruler. Remember, I can use centimeters or I can use millimeters. For this example, I'll be using centimeters. Okay, then you must measure the distance on the map. You must measure the map distance, right? Okay, obviously if you're measuring between two places, you're measuring between dots. So on your map, this will be your map distance. Okay. Obviously, if I used centimeters when I was measuring my bar scale, my bar segment, I need to use centimeters when I measure the map distance. Okay. After that, calculate how many segments of the bar scale it works out to be, right? In other words, in simpler terms, you basically divide the map distance by the length of a segment, right? And then you multiply by the scale. And then, okay, let me give you an example. Okay, let's say you are told to determine the real distance in meters, right? Okay, obviously, you're looking at meters. If the map distance is 25 centimeters, so you've measured using your ruler, right? Using your ruler. Remember, when you use a ruler, you must start here at 0. Start at 0. Don't start here. So this will be wrong. This will be correct, right? Now, let us carry on. Right? So basically, in this case, you measured this distance, right? And I've measured it for you, right? Obviously, our our screens are not the same. So this is 2 centimeters long. One segment of the bar is 2 centimeters long, right? And the map distance, which you've measured using a ruler, on the map is 25 centimeters. So the real distance, it will be your map distance divided by the segment of the bar scale, right? So in this case, your 25 centimeters divided by your 2 centimeters, because this segment is 2 centimeters long, divided by 2 centimeters, right? 25 divided by 2 centimeters times 10. Where does this 10 come from? Comes from there, right? You can also write, you can also do it like this, right? Sometimes the segments are too small. You can actually use the whole bar. Right? In this case, the length of the whole bar is normally represent 20 meters, right? So you can also say 25 centimeters, which is your map distance, right? Divided by, obviously, if this is from 0 to 10, if it's 2 centimeters, right? From 0 to 20, it will be 4 centimeters, right? So divided by 4 centimeters, right? Times this real length, right? This length is 20 meters times 20 meters. Your answer will be 125 meters, right? I think these examples are easy thus far, right? Let us move on. Okay, now the next question of this lesson is I want to show you how to actually determine the scale, right? How to design your own scale, right? How to make your own, in this case, to make your own ratio scale, right? Written in this format. Here's a scenario. You are required to construct a plan of your classroom, right? The actual length of the class, right? So this is your classroom, right? The actual length of your class is 5 meters. The plan length of your classroom must be 20 centimeters. Let's say there's your paper. Obviously, your paper is smaller, it's much smaller than the classroom, right? The length that I have to draw, the length of the class, right? It must be, I'm told it must be 20 centimeters, right? So in other words, 20 centimeters on paper will represent 5 meters in real life, right? So that's what they're looking for. Determine the appropriate scale. So in this case, you need to align your values, right? Remember, the first part of the ratio scale represent the paper, right? What is on paper distance, right? And the second portion of your ratio represent the real distance, right? So in this case, what is my paper distance, learners? It is 20 centimeters. So 20 centimeters, okay, represent in real life, right? How long is the class in real life? If on paper it should be 20 centimeters, how long is it in real life? It is 5 meters. So this is basically how you start. Okay, and then okay, here I've done for you 20 centimeters is your plan length, and your actual length is 5 meters, right? So now, because the scale cannot have units, that means you need to cancel it off your units, right? That means before I cancel them off, they must be the same, right? So I'll leave, it's easier to leave 20 centimeters in centimeters, and I'll be converting the 5 meters to centimeters, right? I know that 1 meter is equal to 100 centimeters, right? So when I'm converting 5 centimeters to 5 meters to centimeters, I'll obviously multiply. I'll multiply by 100, right? So 5 meters is actually equal to 500 centimeters, right? So that is simple, I think. Now, remember my scale must be in the form of 1 to a number, right? So I must have 1 on the left. right? To have 1 on the left, I need to divide 20 by 20. So 20 divides by 20, and you're given, and we have 1, right? Also need to divide by 20 centimeters, right? Now notice the units also cancel out. 500 divided by 20. Answer is 1 is to 25, right? So I've showed you how to determine your own ratio scale, right? I think so far so good. There are no questions, so this must be easy for you. Okay, now let's look at advantages and disadvantages. Okay, the advantage of a number scale, right? Number scale are usually more accurate than bar scales, right? They're actually usually more accurate than bar scales, right? Because remember, a bar scale has this format, right? Where a number scale has that format. Right? So this one is more accurate than this, right? And then another advantage is it provides an idea of the relationship between the plan and the actual object, right? So for example, 1 is to 100, right? So you know that the picture or your map will be 100 times smaller than the actual area, right? So it is actually easy to work to understand in that way, right? If it's 1 is to 100, that means your paper is 100 times smaller than the actual land or the actual area that you're looking at, right? So those are the advantages of a number scale. Now, disadvantage of a number scale, right? It requires calculations, right? Requires calculation to determine the actual length, right? As you'll see with bar scale, sometimes you don't really require, you don't really need to do calculations, right? But for grade 11, I'd advise you guys to do calculations for both scales, right? But here, you always have to do calculations, right? And you have to convert, right? So you can make a lot of mistakes. You need to first determine the actual distance, and you need to convert it to the required units, right? So you can make mistakes in that way. Another disadvantage of a number scale is that when you're printing it out, right? Right? If you enlarge it or you are reducing the map, right? The scale becomes inaccurate, right? If the scale is, for example, 1 is to 100, right? And my map, I'm enlarging it, right? So this will actually be wrong, right? When I calculate the distance using the scale, I'll get wrong values. Let me give you an example. Okay, let's say here's my number scale, right? Let's say this distance, right? Let's say this distance is just on the map. Let's say it is, to make life easy, let's say it is 2 centimeters, right? So the real life distance, right? To get the real life distance, my ratio is 1 is to 15. So I need to multiply 2 by 15 to get the real life distance. So 2 times 15 answer is 30, right? 30 centimeters, right? If I enlarge it, let's say I'm enlarging it by two times, right? This distance will now be 4 centimeters. But the scale remains the same, right? You see, the scale remains the same. If I say 4 times 15, right? 4 times 15 is 4 times 15 is 60. Right? Now, this is actually incorrect. Why is this incorrect? Because it's incorrect because you've adjusted, right, the size of your object, right? The scale cannot change accordingly, right? Unlike with a basket, Okay, let's look at diagram 3. Diagram 3, you can see that I've enlarged diagram 3 to diagram 4, right? The Pascal changes accordingly, right? If I enlarge the object, the scale also enlarges, right? But in this case, the scale does not enlarge accordingly. For the Pascal, the scale enlarges accordingly, right? So that's why this calculation becomes incorrect, because the number scale, right, does not adjust accordingly. Okay, let's look at advantages of a Pascal, right? Okay, these are usually quick and relatively easy to use, right? Okay, they're very, very easy to use. For example, there's your Pascal, right? Let's say this distance, for example, is, right, 5 centimeters, right? And you know that in real life it is 10 meters, right? So if you have a distance of, for example, distance of 10 centimeters, you know that it will be twice as long. So this will be 20 meters. So it is actually easy to work with, right? If you have a distance of 2.5 centimeters, you can see that it is actually now equal to 5 meters. Right, so it is easy to work with Pascals. Okay, in other words, you may be able to determine the actual distance without calculations, as I've showed you here, right? You don't need calculation to see, right, the real distance. Now, when printing, right, if you resize the image, right, the scale remains accurate. In this case, you can see, right, you've resized, right, the scale also changes accordingly, right? The scale also is also resized, right? So this remains accurate. Unlike your number scale, the scale remains 1:15, right? Even though the size of the map has changed. Okay. Disadvantages of a Pascal. Okay, the first disadvantage of Pascal is measurements are obtained using a bar tend to be less accurate, right? Why? Because you actually now measuring that part, right? And also measuring the distance, right? So sometimes learners tend to make mistakes, right? Sometimes for some learners, they'll measure maybe like 5.1, some will measure 5, right? Some will measure 4.9, right? So these increments can actually make your calculations incorrect, right? Okay, Pascals may still require calculations, right, to determine the actual length. Sometimes you, as I've showed you in an example, sometimes you measure the distance on a Pascal and you still need to do calculations, right? Okay, so that's the disadvantage of Pascal. Okay, now this is now your turn, right? I've spoken a lot today. This is your turn. Okay, here is an example. It says Tulabon or Tulabon is a clothing designer. Below is a scale diagram of a shirt he designed, right? Okay, question number 1, explain the meaning of the scale, right? There's your scale. Okay, let me just change my color there. Explain the meaning of this scale, right? What does the scale mean, right? What does the scale mean, right? Okay, quickly, learners, please write your answers on the chat. I'll give you guys a couple of maybe minutes or so to give me the answer. What does 1:18 mean? What does 1:18 mean? I'll give you guys 1 minute to give me the answer. What does 1:18 actually mean? Okay, when you're done, You can just type out your answer on the chat to see if you guys are following. Explain the meaning of 1:18. Okay, let me give you the answer. Okay, explain the meaning of a given scale. 1:18 actually means 1 unit, right? 1 unit, this is 1 unit, right? And on paper, okay, on paper, hopefully you can see my handwriting here. 1 unit on paper, this on, by the way, represents right? In this case, 18, right? Represents 18 units in real life. Units in real life. Okay, this one is simple. Those are easy to marks in real life or in reality. It's up to you. This is F. Okay. Number 2. Okay, number 2 says calculate the scale length, right? The scale length in millimeters, right? Of the sleeve if the actual length is, right? So the actual length, right, is 486 millimeters. So you're given the actual length, right, which is 486 millimeters. I want to know in millimeters what is the scale length, right? What is the paper length, right? What is the length on paper? If in reality the length is 486 millimeters. Again, I'll give you guys another minute to give me my answer. If in reality the distance or the length of the sleeve is 486 millimeters, what is the length on paper, right? What is the length on the plan, right? So give me the answer in millimeters, right? We have 30 more seconds left for number 2. Okay, I don't have much time, so let us continue, right? So in this case, okay, to change from the distance on paper to the actual distance, you need to multiply by 18, right? Because 1 unit on paper represents 18 units in real life, right? So when I'm going back, the opposite must occur. I need to divide by 18, right? So in this case, it will be this figure divided by, it will be 486 millimeters divided by 18, right? Right. If I'm using my calculator, the answer will be 486 divided by 18, right? So on paper, the distance is actually 27 millimeters, right? Obviously, the answer should be in millimeters. This is about 2.7 centimeters, so it should be small, right? Okay, number 3. Number 3, determine the actual number of buttons required for the shirt. How many buttons are required for the shirt? This one is actually easy. If you are, how many buttons are required for the shirt, right? Okay, only count the buttons that you can see, right? Don't count the buttons that you cannot see, right? So all of the buttons are shown on the front view, like this figure. How many buttons do you need, right? How many buttons do you need for this shirt, right? Okay, give you 10 seconds to count. Okay, in this case, okay, let's count together. There's 1, there's 2, right? Okay, Jared says 11. Okay, let's see if Jared Putumelo also says 11. Okay, these are okay. I know these learners are always correct. So let me just verify. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's 10. 10. I can see 10, right? But if you're counting this one as well, even though I can't see it, it will be 11. So my answer in this case, it will be 10 or 11, right? Let's recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you're counting this one, then it will be 11. So I'll give you an answer for 10 or for 11. So well done, learners. Okay, next question. Bacon also got the answer correct. Okay, now let's select number 4. Now it says Tulabone want to sew a single stripe of piping on the back of the shirt, right? That is single stripe as shown in the diagram. Calculate the length in millimeters, okay, of the stripe of piping required, right? Okay, here, okay, this one is tricky because you need to actually measure this distance, right? You need to measure this distance here. Okay. Okay, let's say this distance is on paper. Let's just say it is 20 millimeters, right? If this is 20 millimeters on paper, what is the actual distance, right? Give me your answer on the chat. If this distance is 20 millimeters on paper, what is the actual distance, right? Use your scale to determine the actual distance, right? If on paper, it is 20 millimeters. Okay. I don't have much time, so I'm finishing off, right? I'm finishing off. Okay. So you guys should have said, I'm still expecting my answers, by the way, but you guys should have said the actual distance or actual length, right? Actual length is equal to the map distance. What's the distance on the map or the length on the map? It is 20 millimeters. 20 millimeters, right? Times obviously the real side of the scale, which is 18, times 18, the real ratio of your scale, right? And then 20 times 18, use your calculator just to avoid mistakes. Answer will be 360. They said your answer must be millimeters, so millimeters. Okay, yeah, I'm sure some of you got this one correct as well, right? I can see Jared got it correct. Well done, learners, well done. Okay, last one. State on which side of the button must be sewn on the sheet. State on which side the buttons must be sewn on the front of the. Okay. Basically, they need to know on which side must the button be sewn on the front. On which side the buttons must be sewn on the front of the shirt. Okay, this question seems a bit tricky. but let me see. Okay, see, some are saying left. Okay. I think they must be shown on the right, right? Okay, remember, if this is your head, this is your head, you looking pretty, right? And handsome if you're a gentleman, right? Buttons will go through the top part, so they must be shown on the right, right? So they can appear on top of the left. So here I'll say the right, right? Here I'll say it is on the right. So they'll remember buttons go through you, the overlapping part, overlapping shed, so it must be on the right, right? Some are saying left, but I'm saying right, right? Okay. Now, okay, this is actually all. Okay, appreciate guys your appreciation. My time is actually up for today's lesson, right? My time is up. What I'll require from you guys to basically go through this activity and other similar activities as well, right? You need to know off by heart your advantages and disadvantages of both your bar and number scale. That is very, very important, right? And you need to know how to use, how to calculate distance using your scales, basically. Next, for more information, you can look at past papers, right? From this website, www.education.gov.za, right? Okay, next week we're looking at maps, street maps, right? So today's lesson is the foundation for lessons to come. And then we're done for today. For more information, you can email us on info@africatechnics.co.za. You can also catch us on these social media platforms. Okay. Okay, I think we're done. Okay, so bye guys. See you again next week, same time, same place. Bye.